Okay, so we are about to start the review for Chapter 2, and I just want to go over a little review from the textbook. Now, in the textbook, you have this study guide, and so it has some big ideas and what we can use those big ideas to be able to do, what we've learned in the chapter, so we'll go over those in detail. And also a skills summary on the next page, page 123. And this skills summary basically says, this is what you should know how to do by now. So in preparing for your test, this is the stuff that you should know. Trig ratios. Determine the measure of an angle. Determine the side length of a triangle. Okay? So all using the trig ratios. So we learned about SOHCAHTOA, sine, cos, tan, solving for sides and angles. And if you're asked to solve a triangle, that means that you find all of the side lengths and all of the angles, right? So that will come up to in your review. Okay, so the big idea, the ratio of any two sides remains constant if the triangle is enlarged or reduced. So we talked about this a little bit. If you have a small triangle, and then if you have a large triangle that's the exact same shape, but just a bigger size, the ratios of the side lengths will be the same. Let's say this is 8 and 6. This little triangle will be 4 and 3. The ratio will always be the same. 8 to 6, 4 to 3. Okay, so that's a rule. Same shape, different size. The side lengths are proportional. You can use the ratio of the lengths of two sides to determine the measure of one of the acute angles. So if you're given these two sides, let's just work with this little example here. Oops, and I realize my face might be in the way here. Let's move that down a bit. So if we're working with this triangle right here, and it's a right triangle, then we can find this angle, right? And we look at this and we say, from this angle right here, this is the what side? Adjacent, hypotenuse, opposite, which one is it? This number 6. That's the opposite side. Good. What's this one? It's the hypotenuse. Very good. So which trig function should I use to solve for this angle? SOHCAHTOA. So opposite and hypotenuse right here. Opposite, hypotenuse, I use sine. Very good. So sine of this angle, and I'll just say this is angle A, equals 6 over 8. Or A equals second function sine, or your inverse sine, right? So that's how you find angle A. So angle A is, and let's see, what would that actually be? Second function sine of 6 divided by 8. 48.6 degrees. Okay? That's what that is. So that's how you find an angle. You can also use the length of one side and the measure of an acute angle to determine the length of another side. So what that is saying is that, let's say that you're not given this situation, but you're given this angle is 48.6, and I'm looking for the opposite side. Well, you can use a trig ratio to solve for that, right? We know that sine of 48.6 equals the opposite side over 8. And so O equals 8 times sine of 48.6. Make sure you show your work. Make sure you do this sort of thing. So 48.6, let's do the sine of that number, and we'll multiply that times 8, and that gives us 6. Okay, that makes sense. So you can solve for a side as well. All right. Any questions so far? All right. So the fourth big idea here really is you can just use the prime trig ratios to solve problems that involve more than one triangle. That was the last thing we did in 3.4. Okay? All right, so moving on, what are the skills that you need to know for this chapter? Okay, you need to remember SOHCAHTOA, and this is just SOHCAHTOA right here, right? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So you need to know this, that's SOHCAHTOA. From angle A, the opposite side is just straight opposite of angle A. Hypotenuse is always opposite the 90, and the adjacent is just the other side. Okay? It's beside the angle that's not the hypotenuse. All right, so we talked about this a little bit too. Determine the measure of an angle. It's cos to the -1, right? In this example, take cos to the -1, and that's how you find your angle. That's how you split them up. This is a big no-no. Cos of A, and a student goes, okay, I need to find A. I'm going to divide by cos. That's what I'm going to do. I'm going to divide by cos. Please, you can't do that. That doesn't make sense. You can't do 0.5 divided by cos. Your calculator will say, what are you doing? It'll say error. Okay? It might even start to get hot and smoke and like, what are you trying to do to me? It just doesn't work because this is not, a cos is not something unto itself. It's not cos times A that we can divide it off. It's a part of a function, right? It's a part of a, this is actually one complete unit. So in order to get A by itself, you have to do the inverse of cos there. Okay? All right, and we're going through this pretty quick, hopefully. This is good. Okay, we went through this, determined the length of a side. You might want to just look at this a little bit closer. But you know, you can find either of these two sides using just different ratios. If we want to find the hypotenuse, you're given the opposite and an angle, then you just use sine, right? And you just solve for the missing value. No big deal. Remember the Pythagorean theorem as well, right? If you're given two sides on a right triangle, you can always find the third side. You can use Pythagoras or you can use trig functions. So if I give you 3 and 4 and you're asked for this side, you could use Pythagoras, which says 3 squared plus 4 squared equals I don't know squared, right? That's 9 plus 16 equals I don't know squared. That is 25 equals this missing side squared, square root of both sides. The missing side is 5. You could do that. If you know what this angle is, you could use a trig ratio. If you know what this angle is. If you don't know what the angle is, then you have to use Pythagoras, I guess. But if you know what this angle is, you could use, hey, opposite side, hypotenuse. I know what this angle is. I'm going to use sine. So there's different ways you could do things, but remember Pythagorean theorem as well. Okay? And that's everything that's in that review. So that was really quick. But anyways, that's just a quick summary of what we did this chapter and what you need to know for chapter 3.